most advanced Honda Civic Type R is manufactured inside this Honda factory in Saitama. This is where the Civic Type R's distinctive exterior panels are formed. Deeply pressed body panels, including front fenders and rear door side panels, express the car's low, wide stance and dynamic presence. The Civic Type R uses the deepest pressed exterior panels ever produced by Honda. This Yorii automobile plant in Saitama is the sole facility in the world trusted to build the Civic Type R. While the Civic Type R shares the production line with standard Civics, Honda had to design Type R specific assembly steps that could not be handled by the normal line. Through advanced computer-aided engineering, simulation, and expertly hand-finished molds, these panels are formed precisely using existing equipment. Right now, you are watching how robot arms weld the individual parts of the car body, creating the body in white. This body in white contributes to aerodynamics, helping features like the rear wing, diffuser, and front splitter generate downforce. Welding is a critical process that directly affects handling stability, body rigidity, and overall appearance. Structural adhesives, enhanced beyond the base Civic, improve rigidity, while laser brazing creates an exceptionally refined roofline. The polyurethane topcoat applied to the Civic Type R body is a first for the Yorii Plant and a defining visual element of the model. Its implementation required meticulous material selection and extensive quality assurance, supported by Honda's top painting and coating specialists. Specially designed bumpers are carefully assembled and painted, enhancing both aerodynamics and visual impact, while reinforcing the vehicle's aggressive Type R identity. At Honda's Yorii Plant, Civic Type R production averages about 400 units per month, translating to an estimated 4,800 vehicles per year under steady production conditions. Interior and exterior components, including the powertrain, suspension, and exclusive chassis parts, are installed during final assembly. Dedicated Type R elements, such as front bucket seats, aerodynamic components, and performance suspension systems are carefully fitted. The wider tires, essential for improved performance, required a shift to manual installation to maintain flexibility, quality, and cost efficiency across Yorii's diverse production lineup. The Yorii plant produces compact cars, sedans, SUVs, and minivans, but building the Civic Type R presents a unique challenge. Its character and performance requirements differ significantly from other Honda vehicles. The Civic Type R engine is produced at Honda's Anna Engine Plant in Ohio, USA, while the transmission is manufactured at the Suzuka factory in Japan. These components are integrated at the Ogawa plant, Saitama factory, before being delivered to Yorii for final assembly. As you can see right now, workers at the factory are operating on the main assembly line in cooperation with robots and other machines that assist with many stages of the manufacturing process. However, a large part of the assembly process still requires human workers. And for tasks such as connecting small components, people are better suited than machines. The Civic Type R features a dual-axis strut front suspension, significantly different from other Honda models. A new suspension production process was developed, with 2 associates assembling each unit from start to finish to minimize variation and ensure consistency. Every completed vehicle undergoes a rigorous final quality inspection, including precise front and rear suspension alignment. Some inspection steps are performed manually to guarantee exact compliance with Type R specifications and deliver the iconic handling characteristics customers expect. The Yorii factory has a long history of utilizing advanced automated manufacturing processes. For the Civic Type R, Honda's goal was to honor that legacy while clearly expressing the essence and heritage of Type R. Manufacturing processes developed for the new 5-door Civic served as the foundation. But Type R's unique specifications required the creation of dedicated assembly processes, which were seamlessly integrated into the existing productions line. As one of the final steps, chrome elements such as logos are installed and the wheels are attached. The vehicles are then started and transported to the testing area of the factory, including the dynamometer. Each car is put on a dynamometer, simulating real-world driving while staying in place. Engineers rigorously test engine power, transmission performance, braking efficiency, and noise, vibration, and harshness levels to ensure every Civic Type R performs exactly as designed before leaving the factory. The front and rear suspension are carefully measured and aligned, while engineers ensure precise handling compliance to meet Type R's performance standards, checking components such as brakes, steering, and drivetrain mounts for proper fit and secure installation. Every exterior detail blends striking aesthetics with aerodynamic function, while its turbocharged 2.0-liter engine delivers over 300 horsepower, making it equally at home on the road or the track. Right now, you are watching the disassembly of the Honda V10 engine that powered McLaren to the 1990 Formula One World Championship. This engine earned its reputation as the perfect compromise between V8s, which are lightweight and compact, and V12s, which provide smooth operation and high power. The engineers you see here are the same specialists who hand-assembled this engine over 35 years ago, bringing decades of experience to the process. The engine's sound is legendary among F1 fans, sharp, high-pitched, and resonant, and is often cited as one of the greatest engine notes ever produced. The disassembly takes roughly 15 hours, carried out by these senior engineers who have spent decades at Honda and earn around $100,000 annually. This work happens at Honda's Research and Development Hub in the Supercar Factory, Japan, one of the company's premier centers for cutting-edge automotive and motorsport technology. The facility produces Formula One power units for teams like Red Bull, among others. Right now, you're seeing the engine head being disassembled. This specific unit is the V805 from the Honda RA100E V10, the last Honda V10 raced by the legendary Ayrton Senna. Honda's V10 engines were lightweight, powerful, and exceptionally reliable, fully competitive with Ferrari and Renault units of the era. Driven by champions Ayrton Senna and Alain Prost, McLaren Honda dominated Formula One from 1988 to 1991, winning multiple constructors and drivers' championships. This particular engine was the final Honda V10 Senna raced in 1992, now remembered as an icon of motorsport engineering. Engine serial V805 is the final Honda V10 raced by Ayrton Senna in Formula One, used in the McLaren Honda MP4 during the 1990 season. It powered Senna during warm-up at the 1990 Japanese Grand Prix, and again in the race at the Australian Grand Prix, the final round of that championship year. At the time, standard F1 procedure required engines to be returned to Japan for analysis and eventual destruction. But because Honda was already developing a V12 for 1991, V805 was preserved intact in the archives, making its survival exceptionally rare. Honda's own technicians later disassembled the engine at their Sakura facility. Every major internal and external component, including camshafts, pistons, connecting rods, and cam covers, has been meticulously preserved and placed in a custom display case, complete with a certificate of authenticity. Beyond its engineering significance, V805 represents the end of an era, the last Honda V10, raced by one of Formula One's most legendary drivers, and the closing chapter of a dominant Honda-McLaren partnership. In 2025, Honda Racing Corporation launched its official memorabilia program, with V805 as the inaugural offering. The engine is set to be auctioned by Bonhams at the Quail auction during Monterey Car Week on August 15, 2025, with an estimated value of around $100,000. So, the entire process of disassembling the Honda V10 engine consists of the engine head disassembly, followed by the strip-down work, then the crankshaft disassembly, and finally the pistons. Engineers document every component's position, often with photos or markings, to ensure accurate reassembly. Supporting systems, including the intake manifolds, exhaust headers, sensors, and wiring, are removed first. Special care is required, as Formula One components are built to extremely tight tolerances. The cylinder head bolts are loosened in a strict, predefined sequence to prevent distortion. The head is then carefully lifted from the engine block, exposing the valves, camshafts, and combustion chambers. Camshafts, rocker arms, valve springs, and related valve train components are removed one by one. Each part is labeled and stored individually to monitor wear and enable detailed post-race analysis. Honda engineers measure stress and material fatigue to understand precisely how the engine performed under race conditions. Every component is photographed, measured, and inspected for microscopic signs of fatigue or damage. The data gathered feeds directly into future engine development and performance optimization. Unlike a conventional road car engine, a Formula One Honda V10 is dismantled with surgical precision. Every bolt, spring, and gasket is cataloged and documented. In the case of the V805, the complete disassembly reportedly took around 15 hours. These engines produced approximately 700 to 750 horsepower in 1990, making them highly competitive in the field. They revved to around 13,000 revolutions per minute, delivering smooth, predictable power that drivers could precisely control at the limit. Their compact and lightweight design improved overall car balance and enhanced handling characteristics. While Formula One engines operate at the absolute edge of performance, Honda's V10s were especially respected for their durability and ability to complete race distances reliably. Honda's involvement in Formula One has evolved dramatically since its debut in the 1960s. In recent years, the company returned to the sport with a strong focus on hybrid power units that combine high-efficiency internal combustion engines with advanced electric motor systems. Beginning in the 2026 season, it will supply power units to Aston Martin F1 team. This marks the end of its highly successful collaboration with Red Bull Racing and reflects Honda's long-term strategic ambitions in Formula One's new hybrid era. Honda's recent power units were central to Red Bull's championship-winning campaigns, delivering both performance and reliability at the highest level. With Aston Martin, Honda aims to carry that same competitive edge into the sport's next regulatory cycle. All of this development is centered at Honda's advanced R&D hub in Sakura, Japan, a facility that sits at the core of the company's innovation efforts. Beyond Formula One engines, engineers here are also developing solid-state batteries and next-generation mobility technologies. The Sakura facility was established in 2006 as part of Honda's strategic expansion into advanced automotive research. Its demonstration production line for all solid-state batteries spans approximately 295,000 square feet, representing an investment of about $400 million US, a clear signal of Honda's commitment to future electrification. The cylinder head disassembly is now complete, and the remaining oil is being drained. The next phase of the teardown is known as the strip down. At this stage, the technicians systematically remove the remaining components, breaking the engine down piece by piece. Although the engine contains approximately 2,000 individual components, for presentation purposes in this video, it will be separated into roughly 100 main assemblies and parts. In November 2024, Honda unveiled a demonstration production line for all solid-state batteries at its Sakura facility. The goal is to establish a viable mass production process for these next-generation batteries, which are expected to power electrified models in the latter half of the 2020s. The line features advanced systems for every stage of production, including electrode material preparation, coating, cell formation, and module assembly. Beyond automotive development, the Sakura Center also contributes to technology programs for motorcycles and aircraft. Honda's strategy focuses on scalable solutions that can be shared across multiple mobility platforms, helping reduce battery costs through economies of scale. Today, only a handful of Honda V10s from that era survive in complete or operational condition, making this one exceptionally rare. F1 engines are usually used for development and then scrapped, so surviving examples are limited. F1 memorabilia, especially linked to legendary drivers like Ayrton Senna, fetch high prices at auctions. Collectors buy them for display, museum exhibitions, or as investment pieces that can appreciate in value. These engines are also valued by motorsport enthusiasts and engineers for their advanced technology. Owning a V10 engine allows people to study and appreciate the craftsmanship of 1990s F1 engineering. Now you can see the disassembled gears and the engine's power transmission system. Honda's V10 engines underwent continuous development to enhance performance and reliability. In 1990, the new V10 engine was introduced, featuring refined bore and stroke dimensions for improved fuel efficiency and power delivery. After withdrawing from Formula One at the end of the 1992 season, Honda continued its involvement through Mugen Motorsports, a company founded by Soichiro Honda's son, Hirotoshi Honda. Mugen Motorsports developed and supplied V10 engines to several Formula One teams, including Tyrrell Racing, Footwork Arrows, and Ligier. even securing victory at the 1996 Monaco Grand Prix. The technicians disassembling this engine wear white Honda-issued protective suits and caps, working inside a controlled clean room where precision and cleanliness are paramount. Every movement is monitored, every part carefully handled. As mentioned earlier, the teardown is being meticulously performed at Honda Racing Corporation's Sakura facility in Tochigi Prefecture, Japan, by the very engineers who originally built the engine decades ago. That continuity ensures absolute authenticity. Each component is removed with extreme care, and key parts, including camshafts, pistons, connecting rods, and cam covers, are preserved for auction. Disassembling a Formula One Honda V10 like this one demands specialized tools and exacting precision, calibrated hand tools, advanced measuring instruments, dedicated engine stands, and strict safety procedures. After many hours of patient work, the team is now approaching the final stages of the teardown. Remarkably, despite its age and the immense stresses of Grand Prix racing, nearly every component remains in outstanding condition. The engineers operate in perfect coordination, with at least 2 specialists assigned to the engine at all times. A disciplined, synchronized effort. It's truly extraordinary to witness this 35-year-old power unit, the machine that helped McLaren dominate Formula One in its era. Even after all these years, the internals remain in impressive shape, and once cleaned and serviced, the engine could be fully operational. Now, the team moves on to one of the most critical components, the crankshaft. The crankshaft is the heart of the engine, transforming the piston's up and down motion into rotational force that ultimately drives the car's wheels. It must withstand immense combustion loads while remaining as light as possible. In this 90-degree V10 configuration, a layout Honda favored for balancing performance and smoothness, the crankshaft plays a critical role in both power delivery and stability. Typically forged from high-strength steel alloys, the crankshaft is engineered to survive extreme stress and heat. Each crank pin connects to a connecting rod, and in Honda's V10 design, 10 crank pins are precisely arranged to optimize firing order and overall engine balance. Integrated counterweights minimize vibration, ensuring stability at very high RPM. Engineers also remove every gram of unnecessary material, reducing rotational inertia and allowing the engine to rev more freely and respond faster. The manufacturing process begins with forging under enormous pressure, followed by precision machining to microscopic tolerances. Every crankshaft is then dynamically balanced to eliminate vibrations that could otherwise destroy the engine at racing speeds. Finally, surface treatments such as nitriding or shot peening are applied to enhance fatigue resistance and extend durability, essential for surviving the extreme conditions of Formula One competition. In Formula One, the crankshaft is removed and inspected after every single race. Engineers carefully examine it for microscopic cracks, journal wear, and any signs of surface fatigue. Using ultra-precise instruments, micrometers, dial indicators, and specialized measuring tools, they verify that every dimension remains within exact tolerances. At this level, even the smallest deviation can mean the difference between victory and failure. In this V10, the crankshaft is extracted with exceptional care. If it meets specifications, it could be reused for competition. In the case of the V805 engine, however, it was preserved, destined not for the track, but for display as a rare piece of Formula One history. A lightweight, perfectly balanced crankshaft enables the engine to rev higher, unlocking greater power. Its precision engineering minimizes friction and wear, boosting reliability across the full Grand Prix distance. In Honda's V10 engines, the crankshaft was a cornerstone of both performance and durability, helping McLaren dominate the early 1990s.